go. So we're recording now, and let's share my screen, and we'll come over to our quiz. So again, today we're going over the take-home quiz that's due today. Before we start this, though, I want to just mention the upcoming assignments, the last things that you'll have due in this class before the final exam. So again, the homework assignment that was originally going to be due last Sunday night, because of this quiz, I gave you the extension until Wednesday. But that Wednesday extension, so Wednesday at midnight, is a hard deadline. There's no like 48-hour extension on that for collaborating. And then after that assignment, so end of week 13, there's one more, your last programming assignments posted. We might start talking about it today, but probably on Wednesday is when we'll really finish it up. And we'll be putting everything together into this search engine that we talked about, like very first day of class, and accessing these. You'll be working with some actual like petabyte scale data sets to populate your search engine with data. This assignment will also be due on a Wednesday. So it's the next week Wednesday. And it's the last Wednesday, the last class session before you'll get your final exam. The final exam, you'll get it on that Friday, so a week from this Friday, and you'll have the weekend to work on it. In addition to this last programming assignment here, one last assignment, I'll go ahead and press this submit now, which I think will be a relatively fun assignment, but potentially maybe a lot of work. So this assignment will be due, you have 2 weeks for this assignment due. It's actually due the same day that the final is due. And on this GitHub issue that I just created, there's 9 videos linked below. And all of these videos are like presentations by people at major companies like Instagram or Reddit or Pandora about how they are using Postgres internally at their company to make awesome products. And so the idea of this assignment is that I just want you to get sort of this exposure to what like actual state-of-the-art in industry is with Postgres and big data in general. And I expect, I mean, this should be a relatively easy assignment. Basically just watch the videos, write a few facts about each of the videos. And I hope it'll be a relatively fun and interesting assignment because these are all companies that you know of, maybe have used their products, and seeing how they're like work internally. If you're ever doing interviews with these companies or similar companies, it's cool to be able to bring up like, oh, I saw your video on, like if you're interviewing at Reddit, I saw your video on how you're using Postgres to do this thing, and I know Postgres, and so you should hire me because I can do that. But I also realized that you do have, a lot of people have a lot going on right now. This assignment is worth 9 points, 1 for each video, and so it's, if you can't fit in time to watch all the videos, you're not going to lose a whole lot of points, and I certainly won't be offended if you choose to strategically not complete this assignment. But that said, I think it's one of the more fun, more potentially useful assignments of the course. Any questions about anything admin-wise, what to expect from I don't know, just scheduling or anything like that before we go over the quiz today? Yes.
So like after May 2nd in our finals due, I know there's like a couple things for non-seniors, but do we have any like actual class sessions though?
And then yeah, after May 2nd, so that week for the non-seniors, there's going to be one last programming project. We're going to cover something called asynchronous programming. In Python, there's this weird async keyword, and we'll see how that interacts with working with what are called IO-bound tasks and interacting with Postgres from Python, often an IO-bound task. We'll have a couple of lectures, probably just like Monday and Wednesday that week. And then you'll have until the final exam period to submit the programming project based on that. But if you're a senior, then, or if you're graduating this semester, then this will be your last day of class. Good question. Any other questions? Anything admin-wise? Okay. So then the quiz. How many people thought it was a hard quiz? All right, yeah, that's fair. It was a hard quiz. You should expect that the final exam will be a similar level of difficulty. So today, while we're going over it, you should be thinking and asking questions, not just about like the contents of the exam, what the right answer is to something, but also about I'll be mentioning a bunch of asides about how I would be grading this during the final exam and what are the things that I'm looking for or not looking for. This particular quiz, so I think there's 9 problems total, but if you look at all the parts A's and B's, there's 13 sort of partial problems. And each one of these problems will be worth 1 point, but the quiz will be graded out of 10 points total. So you'll have basically 3 problems where if you totally missed it, got something wrong, it's not going to penalize your grade. And then it's only after missing problem number 4 and on that it'll penalize your grade at all. Okay, any questions before we get started? Okay, so this first problem, you're guaranteed to have a problem that will look like this on the final exam. And hopefully everybody should get full credit on this one. This should be an easy one. That it'll be, so create unique index. And then everything, the only thing that we get indexes for are things that have the unique constraint. And this is a little bit tricky because primary keys do have the unique constraint hidden inside of them. And so I'll just going from top to bottom, we have users, id, users. And then I'm not going to rewrite the create unique index part, but the next one was users, username, and then tweets, id tweets, and then last one, tweet tags, make sure I have room, tweet tags. And then here's where the order matters, that it's going to be in the same order that it's listed in the primary key right there. Id tweets, comma, tag. And the way that you should grade this and the way that it would be graded on the final exam is it's basically going to be an all or nothing thing. That if you get all of these indexes listed right here, then you'll get full credit. If you're missing one, then don't give yourself credit for the problem. Any questions on this problem 1? Just 1 point each. I think, yeah, so the easiest way, I think probably to grade it is counting up the number of problems that you got correct, and that'll be your score at the end. Okay, problem number 2. So again, you're going to have at least one problem on the final. It's going to ask you the scan methods applicable for some particular SQL query. And it'll definitely, it'll be like there won't be any joins in that SQL query. It'll just be from a single table. So there's only sort of one scan of a table that could happen there. And there will always be, no matter what, sequential scan is always one of the options. So that should, no matter what, be in your answer here. And now in this case, we have, from the indexes created above, we have an index both on id users and id username, or id users and username. And one way that we could take advantage of that is a bitmap scan. And one of the special things about the bitmap scan that we saw was that it can take advantage of multiple indexes. So it would be able to use both this index on id users and the index on username right here in order to speed things up. Another last scan method that's possible is an index scan as possible. And if we did an index scan, we would only be able to pick one of the indexes. We would only be able to use either the index on id users or the index on username. But when we're selecting scan methods, we don't have to necessarily include all these constraints in the index part of the scan. When we're going back through the table, checking all the table IDs, we can add the other constraints, check them there. So that's why we're able to do an index scan as well. And in this case, we are not able to do an index-only scan because we have no index that contains both of these constraints right here. So this is the full credit answer. And it's important to make sure that, say, on the final exam or on this one right here, that you're including the index scan and not forgetting that one. Yes? You cannot use an index-only scan on this one. Question is, why can you not use an index-only scan? In order to use an index-only scan, you must have an index, exactly one index that matches all of the different columns that are being used in the query. In this case, we have two different columns being used, the id users and the username column. And if we come back up to our indexes that we have available, we have two separate indexes, one on id users and one on username, but because they're two different indexes and an index-only scan can work on only a single index, we can't use an index-only scan. It would be possible for us to create an index where we could use an index-only scan, but we don't have that sort of index available right now. Yes? For the bitmap scan, you have to use a bitmap scan, or we can also say bitmap index. Good question is bitmap scan and bitmap index scan are synonyms of each other. So either way is full credit. That's same as that. So actually, it's one of the things that's frustrating to me about Postgres and its documentation and its how it relates to the explain syntax. That in the documentation, bitmap scan and bitmap index scan always used synonymously when people are talking about the scan methods. These two things are synonyms for each other. But then we saw before in the explain syntax, it breaks up the bitmap scan into the bitmap index scan and the bitmap heap scan. And that's not really mentioned in the documentation very well. But yeah, those two things would be similar. Either way is full credit. Good question. Any other questions on problem number 2? Okay, problem number 3. So create. We're trying to create an index that makes this query up here faster. Create index on users. And we already have an index on username, but in order for the index to actually be usable, the column, the thing that's inside of the parentheses, must exactly match whatever is either to the left or to the right of the equal sign over here. To the right of the equal sign, we have sort of our variable, the thing that we're going to be plugging in, so we can't match that because we don't know what it's going to be. To the left of the equal sign, again, we already have username, but what we need is lower username in order to be able to match it. And so even if we had some like external domain knowledge that was enforcing that all usernames be lowercase, so that lower username is exactly equal to username, it still has to be present in the index like this in order for the index to be usable. Any questions on problem 3? Okay, problem number 4, they're getting harder and harder. Okay, so anytime you see this sort of idea, or where it's listing all of these things that it wants you to be able to do, and I guess in this case it's actually explicitly telling you index only scan, but if you're seeing the words like avoid an explicit sort, or take advantage of the limit clause, or just create the fastest index you can, then you should be thinking in terms of index only scan. How can I make an index that will give me an index only scan here? And so again, what we need to do is we need to have all of the columns present here in the query, present in our index. And so it'll be create index on users. And then we always order things in starting with the conditions and then going from the most restrictive conditions to the least restrictive conditions, and then ending with columns that are not in the conditions at all. So here, created at is the only thing in the conditions, and then id users. Created at, comma, id users, like that. And again, this is an index that we have to explicitly create because it was not created for us automatically by our unique constraints anywhere. Yes? Question is, here we have the descending operator right here. And actually, whether this index is ordered descending or ascending, we will still be able to do an index only scan on this. So whether you have ascending or descending right here, it doesn't matter. The index will still work. It is never wrong if you see a particular like ordering right here. It is never wrong to include that ordering in the index being created. The only time that it's necessary though is when you have multiple order bys that are going in different directions. That's when it would be necessary. But it is never wrong to include it. So yeah, if you have what's in blue, or if you added either of these two red things after created at, that would be full credit answer. Probably the thing that's just in blue is stylistically the best, but either way on the final or on the quiz is full credit. Good question. Any other questions on problem number 4? Okay. Problem number 5. There's a lot of things going on in problem number 5. I think this is probably the hardest problem on the quiz. And this is also, like, I mean, if you look at it, this is a relatively kind of, I think, innocuous SQL query. Like, it's pretty small. In the first half of the course, we were definitely writing SQL queries that were much, much larger and much more complicated than this. But even on this relatively small SQL query, there's a lot of things going on that we'll have to pay attention to. The first thing that I want us to look at and focus on is just these joins right here, ignoring everything else about this problem. And we said before that you can, when you're doing the joins, it doesn't matter, or the correctness of the result, the like actual values that you get as a result, don't matter what order you do the join in. But you could have performance differences about what order you do the join in. So I might join like users and tweets like this, and then join tweet tags, sort of putting parentheses around the first join operation. Or I might put parentheses around the second join operation, tweets, comma, tweet tags like this. And either way, either of these two things is correct. Which one of these two Postgres will choose to use will depend on a number of factors, one being the indexes that you've created. If you've only created indexes for one of these two options, then only one of these options is going to, well, definitely only one of these options will work. But also it'll think about like how big is each of these tables and use that knowledge to determine which one of these is going to be most efficient. On these problems where it's saying create indexes so that the following query will run as efficiently as possible, that means like we can't make any assumptions about the size of the tables or anything like that, and we certainly haven't talked about how we would choose which one of these two is going to be faster. So we need to create indexes that are going to work for both of these cases, no matter which one is going to be chosen. So what that looks like, we'll start with the top. How do we speed up this join right here between the users and the tweets? We said that the fastest possible join operation is the merge join, and so the merge join can be sped up with indexes by making whatever the join key, in this case id users is, having our entries already sorted so that we don't need an explicit sort step and can just do the sort of merge step from merge sort. Similarly, if we were using a nested loop join, we would also want indexes on id users. That's how we would be speeding things up. So no matter what algorithm's being used here, id users on both of these tables is what we want our index on. So create index on users, id users like this, and tweets id users like this, and both of these two here come from this in parentheses right here. This index right here already exists. So up here when it says do not create unneeded indexes, we're going to have to delete this here in a little bit. But before we're thinking about indexes that already exist, let's just write down all the things that we need. So this, again, this index here, speeding up this join between users and tweets. Users join tweets using id users. Next, we'd be joining on tweet tags right here. And because this is a joined result over here, there's really nothing that I can do, to modify users and tweets so that it would be the resulting join over here will be better for a merge join or a nested loop join. So the only thing I can do is adding another index on tweet tags over here. And so that one wants an index on id tweets. So tweet tags id tweets like this. And so these three indexes right here would make this join ordering as efficient as possible. Postgres might prefer this join ordering though, so we have to consider this. In this join ordering, so tweet tags and tweets will be joined on id tweets right here. So this id tweets, you have to be a little bit careful about where this id tweets is coming from. It's coming from this tweets right here and this tweet tags. And so we need an index on tweets on id tweets. So tweets under parentheses, id tweets like that. And then the other indexes that would be speeding up this join ordering right here, already listed up here, that we have the index on tweet tags, id tweets, and we have the index on users, id users already. So these are the four indexes that would speed up just considering the joins right here, not considering anything else. Any questions so far on where I got these indexes from? Sorry, can you speak up? I can't hear you. Question is, do you have to list all of the indexes for both of the cases? And the answer is yes, you have to list it for both cases because you don't know which case is going to be chosen in advance. And so in order to make the query as efficient as possible, and actually depending on the particular values entered in, say, like tag prefix here, if Postgres might think one of these is better than the other. And so you always want to make all of the different join possibilities possible. So listing off these 4 indexes right here for the joins of these 3 tables. The next thing is to take advantage of this where clause right here. And in order to take advantage of the where clause, again, Postgres could choose to do these joins before doing the where clause. And if that's the case, there's nothing that we can do to speed up the where clause because after we join these things together, there would be no index on this joined table right here, so we can't speed that up. Vast majority of time, what Postgres will do when you have a where clause is that it will parenthesize things so that the where clause gets attached before the join. So in this case, this where clause, we could add sort of parentheses like this, where that where clause will apply to the tweet tags before the join happens. And so, we need an index that will speed up the where clause when it's on this tweet tags query like this. In order to do that, we have to think about this where clause right here. It's got a like operator inside of it. The like is equivalent to the less than and greater than. It's a range of the tag prefix right here. This percent at the end is going to act like a wildcard, and so it's going to find everything starting with all the tags, hashtags starting with tag prefix right here. In order to speed this up, we need an index on tweet tags. I'm going to write out the create index command again, since we're got this thing in the way on tweet underscore tags. And then the columns, well, the column that's going to speed up this where clause is going to be on tag. So we'll have that first, like this. And then in order for, if we had it, if Postgres did choose to parenthesize things this way, after filtering off of the tag, we would want things to be ordered so that we can do the join on id tweets. And so we'd add id tweets over here. It tweets like that. And that's going to speed up the where clause and the join clause. Lastly, this group by. In order to be able to speed up the group by, we would want to be able to do the group aggregate instead of the hash aggregate. And the group aggregate wants sorted input data sorted by id users. With all of this stuff going on up here, though, there's no way for us to guarantee that the results are already going to be sorted, no matter what other indexes we might create. And so there's no way that we can explicitly speed up this group by clause. So that's everything, all the indexes that we can add. The last thing to do is just filter out, remove the indexes that don't need to be created, so that we're not creating unneeded indexes. And so we already had that index from before, and we already have that index from before. And so there's 3 indexes that need to be, let's see, did we have the tweet tags? We don't have the tweet tags because up here the primary key was given in the opposite order up here. And so there's 3 indexes that would need to be created: the tweets id users, tweet tags, tag underscore id tweets. This one right here, I would give you full credit whether you included this or did not include this. The tweet tags underscore or the id underscore tweets. This one, you could use the index created by the primary key right here in order to speed up that part. Having it be only a single column would be slightly faster than having it be multi-column though, so this will slightly speed things up. So you get full credit whether you included this one or not. have to include that one and that one. This one right here would be optional. On the final exam, you can expect at least one question of this level of complexity. It's basically integrating everything that we talked about into a single problem and really having to understand all of those things in detail in order to get the final results. Questions, Dustin?
Yeah, so can you really go over why the last one needs to specify ID tweets with the second column?
Question here, if we had tweet tags and then just tag without ID tweets, what would happen? The reason that I'm including both tag and ID tweets right here is in this where clause. If we have, if we first filter on the tag, then if we first filter on the tag, then we're going, if we don't have ID tweets, then there's no way that we can speed up the join between the stuff in parentheses right here and everything else up here. But by having ID tweets over here, then whatever our tag is, say it's coronavirus, and then all the tweets that correspond with coronavirus will already be in sorted order. And so we'll be able to take advantage of that sorted order for this join right here, doing a merge join. On a problem like this, on the final exam, so these problems on the final exam are going to be worth roughly about 10 points-ish each. And this would be something that there would be lots of opportunities for partial credit on a problem like this. The previous problems, probably not much room for partial credit. But this, if you had something that was like, I don't know, maybe missing this last line or had it in the wrong order or missing the tweets, you get some partial credit for the problem. For the quiz, purposes of the quiz, it'll be either full credit or not credit. So we'll go right to left. Yes, so.
Like for the join operation, you would not have to have the column that you're determining on the order. But if you have it in the second position,
question is, if we have this in the second position, are they going to be ordered? Let me, I'm going to open up another window here where I can draw something. And there we go. So the way the multi-column indexes work, and this is definitely going to be coming up on the final exam in some way, is that if we had things, so we have a multi-column index, I'll say that the first column will be represented with letters like A, B, C, second column with numbers 1, 2, 3. And so if we have, say, like A, comma 5, and could have B, comma 6, and D 1, like this. Here, so this is the root of my B tree. I have 4 things coming off of here. And up here, it's the second column is not necessarily ordered. That here the 6 happens to come after the 5, but here the 1 comes before the 6. But what is going to be true is that after you hit a particular letter, so down here maybe we have all the D's, we'll have D1 and D3, maybe D7. that the second columns will be ordered conditioned on the first column being equal to a particular value. So once we have specified that the first column is going to be coronavirus, then if the first column is the tag, then the second column being the id tweets, those id tweets are going to be ordered, and Postgres will be able to take advantage of that.
But it's not coronavirus, right? Cool, like it has a like at the end, like it's a wildcard symbol, so it can potentially be different.
Yeah. So how am I going to draw this out? If we had D5, maybe DA, that could go like, so you're suggesting that we have, if these are supposed to be ordered from top to bottom, that we could have something like this now, where DA comes after D in the sort of ASCII-betical ordering, but this is causing the second column to be lower than. And you are right that in that case, this id tweets in the second column is not going to be as much of a help. It turns out, though, having a partially sorted list, so it turns out it's still a big help, though, for two reasons. One reason is that having a partially sorted list greatly speeds up the speed of sorting, because there's a lot less sorting to do for something that's partially sorted like this than something that's not partially sorted. So this still will speed things up. And depending on what the tag prefix is, it's possible that things will come out, like if it only matches one tag, it's possible that it'll come out so that it will actually be a sorted list. So I agree that in practice, like having tag by itself versus tag comma id tweets, in some situations might not add much of a performance difference. But since it is asking for like the most efficient thing possible, this will add a little bit of performance difference in all cases. Some major performance boost when the tag here actually only gives one result. And so this is what I would be looking for still for a full credit. Does that make sense? Okay. So a couple of rules of thumb. If you have a where condition that can be grouped with a one of the tables up here, it's possible that you have where conditions that can't be grouped with them. If, for example, the where condition mentions two different tables, you wouldn't be able to do a grouping like this, parenthesizing things. But if you can, it's basically guaranteed to be faster that way. And you'll want to make your indexes so that it groups whatever's in the where clause first, and then whatever is in the join condition second. Yeah, so general principle on a problem like this where you have join clauses and a where clause is that essentially universally, I can't think of a situation that would be a counter example to this. So essentially universally, you will want to do the filtering, doing the where clause combined with the join clause like this. So putting the parentheses like this, doing the where before you do the join. And in order to make that as efficient as possible, you will do the tag. So whatever your column is that you're mentioning in the where clause, put that as the leftmost column. And then whatever your column is that you're joining on, put that to the right. Thinking of this as basically a select this column right here, where this condition right here. Question is, what if this where clause was on a different table besides this one at the end? And the answer is that you can, so it happens to be that this where clause is on the very last one, so I can draw the parentheses like this and it looks nice. But if this where clause was on the users, like where user ID equals something, you could move that where clause up to the users table as well, just fine. But yeah, the where clauses can be moved around to wherever wherever it makes sense to apply them. Good questions. Any other questions on this problem? Yes.
I was gonna say, if we didn't have the optional tweet tags,
So for the quiz, just to really drive home the point of what the most correct answer is on the final exam, I want you to have so you have to have the top one, the bottom one, the middle one, totally optional. The for the final exam, if you had some variation on this bottom one, like not including this second column over there, you would still get most of the credit on the problem. But for the purposes of the quiz, to make things simpler, just everything's full credit or not full credit. But this middle one, optional.
So we didn't have the middle one. Okay.
Yeah. Questions? Any other questions? This question? No? Okay. Okay, problem number 6. So this one is, I think, a lot easier than the previous problem. The thing that's only tricky about it is that before, when I had these sort of simpler queries like this, I was specifically telling you, trying to, or give you hints to do like index only scan or something. Now it's just saying create queries as efficiently as possible, not telling you what kind of scan methods maybe to try for. But in this case, the query is, or the index is create index on tweet tags of tab, like that. So what we have this group by right here, and what we're trying to speed up is we're trying to speed up the aggregate operation on this count star. And we said again, there's two aggregate methods. There's the hash aggregate and the group aggregate. The group aggregate is faster, has lots and lots of advantages, but the disadvantage is that it needs sorted input. And so in order to do this group by with the group aggregate, we need to have the inputs be sorted on the tag. And this index will do that for us. In this case, this order by and this limit, though, we can't really speed up either of these two operations in any meaningful way. So is this limit clause likely to speed up the query? I'm going to, let's see. The answer that I think is the easiest one to explain why it's correct is a no right here. And so we'll say the explanation here. There is, depending on how you interpret this word significantly right here, there is a way that the limit clause can speed things up. So I'll say that later. And if you have a yes with that second explanation, then that would also be credit. But the no explanation, really the most important thing here to identify is that because we are ordered by count right here, we actually have to look over the entire data set, the entire tweet tags table, in order to know what the count is. This create index right here gets things ordered by the tag. So if I wrote out like the tags, might look like something like, here's our tags, and then some Bs, and then a C, and then a D, like that. And it's ordered alphabetically on the tags, not on not on the count of the tags. And so in order to, as I'm scanning over this, in order to know which tag actually has the most items associated with it, I actually have to scan over the entire table. And so the reason that this is a no is that you still must scan the entire table. And so if you wrote something like a no with some answer that roughly looks like this, and I'll let you use your own judgment on the quiz here to see what looks like this, then that would be a full credit answer. If you wrote a yes, there is still one way which this limit clause does speed up a little bit our answer, and that is that this order by right here, this order by clause must perform a sort. So order by must perform a sort. And the reason that this must perform a sort is basically for the same reason up here, that the information is not sorted according to the number of tags. And we saw there's 3 sorting algorithms. One of those sorting algorithms is able to take advantage of a limit clause. It's called a top heap in sort. Top in heap sort has a runtime of O of n log n plus little n, where the big N is what we're doing the limit on. And the little n is the size of the table. And so there is, without the limit clause, this would be O of n log n without the limit. And so this is like asymptotically faster than this. By my sort of intuition of what the word significantly means, that's not like a major speed up. We're still super linear time. When I think of significant, I think of like going from linear down to logarithmic. But if you were to put yes with an explanation like this with these 2 equations, that would also be full credit. Yes? So that's incorrect. No credit on the problem.
And also, like for the thing on board, we only have like a great index on tags.
Sorry, can you say that again?
Like for the number A. For the number A.
For A?
Yeah. We have great index on tags, but in the previous row we have like great index on tags.
Yeah, so the question is here on problem A, what if you've already in one of your previous problems created an index that looks like this, and should you rewrite the index, or what should you do? And the answer is that both for the quiz and for the final exam, you would get full credit either way, whether you rewrite the index if you've already written it, or if you just say, I don't need to create a new index because I already created it. The only indexes that you definitely should never rewrite again are the ones that are listed up here. Good questions. Any other questions on? Yes. Question is, if you mentioned the top in heap sort, but you didn't write the equations, you can give yourself full credit on this quiz. For the final exam, I think in order to really make the explanation about why sort of detailed enough, I would want to actually see the equations as well for full credit. But if you just mention top in heap sort for the quiz, you're definitely on the right track, so you can give yourself the full credit. Oh, yeah, Julie.
Give me an example of an order by that would help speed up with someone.
So an example where we would get significant speed up. So what if we had something that just looked like select star from, tweet tags limit 10. Now here we're going to be doing a sequential scan. There's no where clause, anything that might filter us out that would help that would make an index be better. And because I have a limit 10, I only need to see whatever the first 10 tuples are in the heap table. I don't need to keep going view the whole table. So this is sort of the most straightforward example where a limit clause can give you like really good asymptotic speedup. But if you have a index only scan, which I think we might have some examples up here. Yeah, like so this right here, we'll be doing an index only scan on this table right here, and we would be able to take advantage of the limit clause here because things are already in that sorted order. Does that make sense?
So does it depend on which scan is being used and whether that scan is going to take advantage?
And if, yeah, so question is, does that depend on which scan is being used and whether the scan can take advantage of the order by, and in particular, making sure that the order by matches whatever the scan is happens to be ordering by. So because this order by matches this index, it works.
And then just to be clear, are the only scans that can take advantage of the clause a sequential scan and the index scan?
Question is, what scans can take advantage of the limit clause? And the answer is any scan except a bitmap scan can take advantage of the limit clause. One of the limitations of the bitmap scan is that it cannot take advantage of the limit clause. And the main way that that comes up is that if you're using a GIN index, the only scan type of a GIN index is a bitmap scan. And so a GIN index can never take advantage of a limit clause. Good questions. Any other questions? Yeah.
If you have a index only scan, like, does the limit actually like significantly drop the time or like?
Question is, if you have an index only scan, does the limit actually significantly drop the time? And the answer is yes, it is very significant. So here up in problem 4, this limit right here, without the limit, then this would be an O of in operation. It would get everything from the table if, say, created at was like the current time. So everything is created at a time less than now. But with the limit clause right here, it's literally only going to look at 10 tuples. So that does give a huge asymptotic performance. The reason why web pages like Google or whatever your favorite social media website is, Twitter, Facebook, Reddit, all these, or like Amazon when you're looking at products, why all of these web pages only give you like 10 items at a time or 100 items at a time is because they're adding this limit clause right here into their SQL queries in order to speed up their index scans. Without those, it would take a long time, even with the index. Yeah.
Can the limit clause ever speed up aggregate functions?
Question is, can the limit clause ever speed up aggregate functions? Let's see. So the main way that a limit clause combined with an order by is going to speed up aggregates is by using that top in heap sort. I think there are probably other ways that limit. Yeah, so if, let's say in this query right here that we had up here, this query right here, if we did not have this order by right here, if we did not have this order by, then this limit right here would asymptotically speed up our computations. The reason is because, let's say we had, let's just imagine this is a limit 1 right here, just for this example, without an order by, or if the order by was on order by tag, then we would be able to stop our scan of the index right here after the A's and be all done. So a limit can speed up an order by asymptotically. It's here the reason why the limit can't speed up this one asymptotically or can't get it sublinear is because the thing that it's ordering by count is not part of any index. This count is something that is being computed on the fly. And so because this is actually like a function that we're ordering by, we can't speed that up. If this was not here, or if this was ordered by tag or ordered by something that was in an index, then we would be able to speed it up with the limit clause. Lots of good questions. Any other questions? Okay, and we're on number 7. So yeah, here we have the, we're starting to get into the full text search. And so the RUM index is the index that you're mostly going to want to use for full text search. It's sort of the standard at this point in the Postgres world. And the actual create index command is super long and complicated. And it's something that I always have to look up actually whenever I'm doing it. But so create index on tweets. First important part here is that you say using RUM. And then 2_TS vector text. And then this weird RUM underscore TS vector add-on ops, TS vector underscore add-on underscore ops, and then a comma, created at closing parentheses, then the with clause, with attach the column that is the TS vector, the thing that we are attaching to, attach equals created underscore at, and then the thing that we're attaching to equals, and then the 2TS vector text. Something like that. There's a lot of different ways that you might have formatted that. It's a huge, big blob of text. But that's the index that's going to speed this up. Any questions? Yes.
What if we had everything and forgot to write the 2TS vector? Like we just put TS vector, I don't know.
So if for the purposes of this quiz, if you're missing something, then it'll just be a 0 on the problem. You missed the problem. On the final exam, I would be something like that. You're missing just one of these clauses. I would be obvious as soon as you type that into Postgres, you'd get a syntax error and be able to fix it. And so you'd get good partial credits. Before this quiz, it's either full credit or no credits. And again, you have those extra buffer points. So hopefully that will make up for any of the extra stricter grading things resulting from the quiz. Good question. Any other questions on this problem? Okay, part B. So if we were not able to create the RUM index, then we have to use a bitmap scan using the gin index. So it'd be, we'll start off with the create index on tweets using gin, and then with the 2ts vector text 2 underscore ts vector of text like that. And then a second index, create index on tweets with the created at like that. And then it would be able to and the results of the bitmap scans on both of those two indexes to speed up your final query. In practice, the rum index is actually surprisingly faster than these two indexes together right here, because the rum index is not going to be touching the heap table at all. These indexes will have to touch the heap table. And the rum index, again, able to take advantage of the limit clause, able to get things back to us in a sorted order, whereas the bitmap scan from these two indexes not able to do that. So on any sort of application of any moderate size, you would notice a huge performance difference between these two sets of answers. Any questions on this problem?
In general, do you only build bin and rum indexes on TS vectors?
Question is, in general, what types do you build the gin and rum indexes on? TS vectors, JSON, and arrays. Anything that sort of has like components inside of it is what you use the gin and rum indexes on. Technically, you could use a rum index on the JSON and the arrays. And I guess it would make sense to do that in order to get the speed up by being able to do a limit with an index-only scan, or sorry, an index scan. But I've never had an occasion to want to do this sort of attaching onto one of those columns. Good question. Any other questions on this problem? All right. Okay, so the query above cannot be sped up using an index. Why? The answer is the unnest function is a set returning function. And so the only thing here where we might think that we might be able to speed something up would be with this where down here, but this where's being applied to a set returning function can't speed up set returning functions. So anytime you see this unnest in a query, it's like a danger flag. There's a good chance you're going to have a slow query in there. So rewrite from the previous question into equivalent query that can be sped up using an index. Do select id tweets. So up here, the query has a select star from, there's two columns listed down here, id tweets and the actual lexeme itself. So if you just put id tweets, that's okay, because that's sort of like the actual main important thing. But the most technically correct would be this colon lexeme as well. So I'll say that's optional. From tweets, where, and then the 2ts vector text double at 2ts query, and then the colon lexeme like that. So that's the query itself that can now be sped up. The index that does so looks like, I'll put it in a different color. 1 second. create index on tweets using gen on 2ts vector text. Question?
Yeah, what if you don't put the next name in the select? Can you still use it in the test, right?
So this up here is totally optional. If you had this column added as part of the output or not, either way you'd get full credit on the problem.
Yeah, I'm just asking about the test squaring that right there, because like since like C is not like name disabled inside the key statement.
So the idea, anytime any of the like words, sort of variable names contain the colon in front of them, is that this is the syntax from that SQL Alchemy Python library where a user is substituting in some sort of text here. And so this lexeme right here would be, for example, on Twitter, they have their own search function. And when somebody types in a word, like, I don't know, I'm searching for Trump in Twitter, then that word Trump gets replaced by lexeme right here.
So like it would be, you can like put another thing right there, like anything is gonna work. Is that right?
So anything that has this colon right here, you should think of it as arbitrary user text. Could be whatever the user wants it to be. Yeah. And so the colons will only ever appear inside of a select query because that's where arbitrary user text can be. You would never have arbitrary user text inside of a create index command because you're not creating an index based on something that a user types in. You're creating an index in advance so that when a user does type something in, it's already going to be faster.
So what if we selected in tweets and then unnest this vector to array and then did the from tweets the same person?
Question is, are there other things that you could have put here for this problem? The answer is yes. There's a sort of basically an unbounded number of variations on these select queries. If you think what you have is correct, but it doesn't match what I have up here, then show it to me after class and I will look at it and say whether it's the same thing or not and give you the points accordingly. Yes? Oh, question is, could we use a rum index instead of a gin index here? And yes, that would be perfectly fine and in practice better, yeah. So anytime on the answers where I'm typing out gin, feel free to substitute rum and that is good. Good question. Any other questions? Okay, almost done. I want to take a quick diversion over to P-SQL for a second and actually type in this this query. So right now I'm in the tweets normalized database. There's no indexes or anything. And I want to see what happens if I create an index on tweets using gin 2_ts vector text like this. And if I hit enter, you'll see that I get an error message saying functions in an index expression must be marked immutable. This 2ts vector right here, remember there's two forms of the 2ts vector function where we either specify the language or we don't specify the language that's being passed in. The 2ts vector function right here is not, I'm not specifying the language. And so the language that it's using is whatever the system language is. The system language could potentially change. Like, I don't know, the system language is currently English, but somebody could change the system language to be Spanish or something else. And if that happens, then this function would return something different. And so this index would suddenly become invalid. In order to make this index really the most correct, you want to actually specify the language like this. And this is what you have to do to actually create the index like that. So now it's actually able to create the index. So over here for this 2TS vector, you get full credit if you didn't actually specify the language, but really in order to actually make this a correct answer and on the final exam, in order to get a full credit answer, you'd have to specify the language right here. And if you specify the language, or if you, whatever the contents of your inside of these parentheses are right here, they must exactly match whatever you have in your expressions over here. So up here, we would also need to specify English in order to actually use this index. So whether if you probably didn't specify English on the quiz, you get full credit for not doing it on the quiz. Final exam, you'd need to specify the language because that's actually needed to create the index. Any questions about that? Yes.
So for these things, you may have like more than not just English to be specified, like both.
Specifying anything would be fine. Okay, last problem. Really quick. So what join methods can be used to implement this query? Again, we're using a cross join right here. A cross join, the only thing that can implement a cross join is a nested loop. And as an aside, a long time ago when we were first introducing the idea of a cross join, a couple of people asked, like, what is the motivation? Why would you ever want to use a cross join? That seems ridiculous. But here is an example of a real world query that like a company like Twitter might run on their data set that uses a cross join. And it is the only way to implement this query. The idea of this query, the semantics of this query is to find all tweets that mention a particular user ID. The user ID is not directly included in the tweets. The user itself is. So somehow you have to get that user information, and this join is how you do that. And so the cross join, nested loop, only way to do it. If it is possible to speed up this query, do so. So cross joins can still be sped up. Let me write the answer here because we're almost out of time, and then I'll take questions afterwards. Create index on users id users. So again, we're trying to speed up this and clause in the where clause right here. This would get sort of filtered up to the users, filtering that out first before doing the cross join. And then similarly, creating an index that's going to speed up the full text search there. So create index on tweets using either gin or rum. I'll just write out gin. And then the 2TS vector. Again, real world, you'd have to specify a language. You get full credit if you didn't specify a language, though. Text like that. This would be a full credit answer. We're pretty much out of time, so I will definitely stick around and answer questions that people have. But if you don't have questions, feel free to tally up the points that you have. And again, it's out of, or there's 13 possible points that you could get, but the quiz itself will be out of 10. And if you happen to get more than 10, then you'll get 10 on the quiz. If you wrote down something more than 10, I'll just edit that before entering it into Sakai. Get your quizzes, pass them up to me, and I'll answer questions that people have. Yeah, that's it for class for today.
just like, we don't need the ID users in the test because it's already.
Oh, okay. Say that again?
It's already like a index, a primary key index, the user.
Oh, yeah, good question. And so on this last one, I included this users aid users right here, and I forgot to get to the step of crossing it out because we already have that created. If you're just dropping it off, feel free to just throw it on the table, and then I'll answer questions.
So for number 8, rewriting the query, would this query work?
This technically gives something different. This will give all of the hash, all of the words in the tweet that are where the tweet contains that particular lesson.
Okay. Okay, that makes sense. Thanks.
Sorry, what's the question? Oh, is that correct?
Yeah, very.
You just said it over there. So this right here says 2TS query.
Yeah.
So the index, create index should always, it has to exactly match whatever is to the left of the at.
So,
So to the left of the at, you have TS vector to array, 2TS vector. So because that doesn't exactly match that, it can't split it up. If it matched, then so this syntax, I have to look this up. This syntax is the JSON kind of syntax. Technically, you're converting your TS vector into an array instead of into a JSON object. I don't think you can use the JSON kind of syntax on the array. So I think in that case, it still wouldn't work. It's the idea is right. It's very verbose. Does that make sense?
My question is just like right here. The only reason why I actually use the TS vector, like necessarily join only, is just because we say that in the first one we're talking about all the different you can only use the quality in the past, not the past. So like can we use even if like can we use like merge
No, because there's no equals condition.
Okay, so like that's like specific to like another user. The equality only like makes the other yeah, because like I was like that's what I do and like things right here. And then like I press these down because I felt like already created them like in the past. Like over the thing. So like
That's fine. You can either recreate things you've already created, or you say that you've already created.
I mean, the only thing that I missed that was this one. I didn't like reading about this one. Also, something. I think I missed another point somewhere. But I could be about this. The other thing is gonna be like I'm gonna compare service. Not like I'm like really, I don't know like how to speed up like a. For instance, if you have like a subquery, if you want to speed up the whole thing, then you have to speed up the subqueries alone, and like how to do that. Because I feel like we had like an right here where like we had that nest, and like then the thing is different. Like, what if we do have that nest?
That'll be a long discussion, so let's talk about that.
Awesome.
So for number 1, what a unique index you created, if it was like either only unique or only not null, would you the conditions for?
All you need is the word unique there. So the fact that it's not null has no impact on the index.
I see. And then I was reading your notes, and then it said for an index scan, you just need an index on one of the columns that's mentioned in the where clause. So you don't need it on like all columns.
That's correct.
I see. but to be the most efficient, you'd want an index on all the columns mentioned?
And that would enable the index only scan.
Okay. Yeah, okay. And then for joins, so did you say that the where clause could be attached to like any of the tables mentioned?
So in this case, it's attached to this table because the tag column only exists in this table.
Mhm.
But if it was like the id users column, then you can move it to the users table because that's where that column exists.
Okay, so no matter where the code is, like the where clause could be parenthesized to the table where the column exists originally.
Exactly.
Okay, so in these kind of questions, you want index on the join column for both tables and ideally also an index for the where clause where the column name is the leftmost and then followed by the join column of that table that has the where clause column. I see. Okay. And then will we ever see like a multi-column gem or run index?
So this is an example of a multi-column
Okay.
run index.
So like when you have something else that's not a TS or that's not really a full text search, but you want to order by or it's in the where clause.
Yeah.
Okay. Then for number 8, since it tweets is being selected, like we already have an index on it, but would having the index on tweets and tweets speed up the query?
That doesn't help because the condition, so here this where clause right here on the lexing was only about this right here. It's not related to 8 tweets at all. So it doesn't, that particular index doesn't help.
Okay. But it would help if we didn't have to use a gen index, because then it could use an index only.
You'd specifically have to have a condition in the where clause that affects id tweets.
Oh,
So
okay.
something like id tweets greater than something.
Okay, I see. And then for the last one, like I guess similar question, would it help to have an index on users, ID users?
And yes, in fact, that's part of the so down here, that's this index, which is you need, but it's already given to you.
So what's the difference between like not needing an id tweets index here to speed it up, but then wanting a user ID users?
So here in the where clause, it specifically mentions the users.users.
Mhm.
And so that's why having an index on it will speed it up.
Okay.
Because there's a filter that you're doing in the where clause.
I
The
see.
other one doesn't have that in the where clause, so there's no filtering we can do to form the index.
Okay. So you want indexes on the columns that are mentioned in the where clause?
Yeah.
Okay. All right. Thank you.
Yeah, so I have a quick question. So I created my indexes and put them in a separate file, and I was testing it out on the smaller database, and it seemed to be running very fast. But then when I got rid of all my data and reloaded it yesterday, and
the big
built,
database?
Yeah, but the big database, it seems to be running just as fast as like before I created the indexes, and which makes me think that the indexes are just not being created when I build Docker, so I rebuilt the container.
So you'd have to, I'm going to use the /d inside of pSQL to check. And if they're not created, it's perfectly fine to just copy and paste those lines into pSQL rather than figuring out exactly what the step is that's not happening to make it happen automatically. Yeah, you're right. So there's no indexes. So don't go through the figuring out like reloading it and everything. Just copy and paste the command, the create index commands that you hear to create them manually.
Okay, sounds good. I'll do that. Yeah, I wasn't sure why, but I'll go ahead and do that.
I want to ask again, like, do I have to reload the data every time I want to update my indexes?
No.
I tried bringing this survey down, like,
So by update the indexes, you mean get rid of the indexes? And
or have it like lower the one in indexes?
Let's see, if you already have a certain index created, why would you want to reload that created? I'm not sure what you mean.
Like, if I edit my indexes, I used to do my indexes, I would automatically update them. I have to do that manually.
Yeah, so the thing to do is just drop the index, like actually typing into T-SQL drop index, the old ones, and then copying and pasting the new ones in there. You could go through the step. It would be automatic if you went through the steps of bringing everything down, deleting the old database and all that.
But take that one.
Yeah, so don't do that. Just
I did this.
okay.
I would do that as well. Also for number 3, I wanted to ask if one index would be able to like solve it.
So let's see. In my solution, I have 3 B indexes total. I forget exactly like which ones are on which ones.
The ones I have now are D, and then 1 gin index.
Mhm.
But I guess I'm not sure if it would like, you know,
What do you mean it would be enough?
I don't know. I haven't been able to test my indexes because I've been learning data all class.
So the thing to do for testing them out is to use the last week's homework assignment, the parallel one. So it's all like you can just create the indexes in a couple seconds, and you won't like see.
Then I can use timing.
Exactly, and so it won't be like dramatic increases from like minutes down to milliseconds, but it'll still be like 100 milliseconds down to 10 milliseconds or something. And it's using the index.
And then, and then for the D, from my database, are we gonna have to use the JSON stuff to like get the info?
Exactly.
Okay. Got it.
Thank you for your help.
Sure.
And I wanted to ask, like, are you gonna hold additional office hours leading up to finals? Because I, myself and Katie both can't make their regular office hours because we're in class.
Yeah, if you post an issue onto GitHub asking for it, then I will. I'll see what I can do. My availability is generally pretty limited because of having the kid right now and needing to be doing things for that. But I'll make sure to work something out so that everybody's able to ask whatever questions you need.
And then for the issue, would it be like asking for a specific time or in general?
Proposing specific times would be good. I think on the main README for the class, there's a link to like my schedule, so you can find things that are hopefully open.
Then for like a specific office hours question. Great.